Welcome back to Greenplum Summit 2020, the Reimagined Digital Customer Conference. My name is Jacques Eistak, and my next guest is our very own Greenplum guru, Mr. John Roberts. John is going to tell us how to embrace the cloud for cost savings. So John, tell us how.
Okay, great. So as Jacques said, I'm the Greenplum guru, so I have a website, greenplumguru.com. But today, we'll talk about VMware Tanzu Greenplum in the public cloud marketplaces. I oversee the products out there in Amazon, GCP, and Azure. In this presentation, I'll discuss some of the ways we have leveraged not only how the IaaS providers have how they charge for cloud resources, but also the features they have that you can leverage to reduce your cloud spend. So did you know that there are many ways to save money in the cloud? So oftentimes you go to the cloud to save money, but there's also other techniques and strategies you can use. So the VMware Tanzu Greenplum products in the cloud have been optimized for each cloud environment with cost in mind. For example, there are many different disk types in Amazon that you can pick from, and you can certainly actually overpay for that storage in Amazon, because sometimes those more expensive disks don't necessarily equate to better performance for Greenplum. The number of disks, the type of disks, and the instance types all play a factor in the performance, but also cost. And we've spent a considerable amount of time optimizing the configuration so that it performs well and the cost is minimized. And so there are many unique ways in which you can save money by leveraging the features afforded by not having to manage the actual physical infrastructure and billing for virtualization. So you know on-demand billing, most likely, so that just simply means you pay for the compute resources when you're using them. So you stop a virtual machine, you're not paying for that virtual machine. And you can know that you can dynamically scale resources up or down by adding more virtual machines. But if you thought about changing the configuration of a virtual machine itself to scale, and we've taken advantage of that to make it easier to scale your Greenplum cluster in the cloud. You know that storage cost is based on how much storage is provisioned, but you can also grow that storage dynamically when needed, and that is another mechanism to help save you money when you deploy to the cloud. And you probably know that the public clouds have methods to monitor and replace virtual machines that become unhealthy. But if you thought about how that feature in the public cloud can actually be used to help you save money, well, we have some features around that. Backups are critical to the stability of a database, but if you thought about how the price tag associated with it, with different strategies, what the actual price tag are, because in the public cloud, there's different ways you can leverage the IaaS to actually reduce your backup cost. And lastly, a disaster recovery solution is oftentimes something you just aspire to get. It's only reserved for very large organizations that can afford it. But in the public cloud, there's ways to actually create a disaster recovery solution that's quite affordable and actually easy to implement. We've been talking a lot about how Greenplum can run in Kubernetes and on vSphere, but Greenplum can run anywhere. It's the same software, whether you deploy on Kubernetes, in the public cloud, private cloud, so forth. It's the same software, same license, and same support. Next slide, please. So currently, Greenplum is available in Microsoft Azure, Amazon AWS, and Google Cloud marketplaces. You can either use the BYOL or bring your own license products or an hourly billed products. And it's all available in all three clouds. You can purchase the license from us and then deploy it in the cloud or in the data center or a combination of both. We don't have any kind of switching fees or anything like that. So you can come up with the best implementation of Greenplum, whether it be in the cloud or on-prem. And all marketplace listings are routinely updated with enhancements and new releases of Greenplum database. We're constantly iterating and improving the product. And as I said earlier, the configuration has been optimized for performance and also cost savings. You probably know this, but did you know that public clouds provide a substantial discount for 1 to 3 year contracts? In some cases, the discount can be up to 60% or even more. So the rates are listed by the hour by each cloud, and the cost savings figure they use is based on the effective hourly rate of the on-demand price versus the reserved license price. To annualize this discount, you simply need to multiply the discounted rate by 24 hours a day, 7 days a week, and 365 days a year. Next slide. But you know it can actually be cheaper to use the on-demand pricing. So how does that work? On-demand has a higher rate, right? But than the reserve. But with reserve billing, you don't get your billing suspended when you pause or stop a virtual machine. You pay for the virtual machine regardless if it is running or not. So for comparison, if you take the Amazon on-demand cost versus a 3-year reserved cost, and you only use the Amazon on-demand deployment of your virtual machine for less than 16 hours a day on average, that is cheaper to use the on-demand pricing option. So how? That doesn't make sense, right? So click, please. So if you take that same equation as before, but with a higher on-demand price, but now instead of 24 hours a day, you're using just the average number of hours you're actually going to deploy the cluster times 7 days a week, 365 days a year, and you get actually a lower cost. Again, for Amazon, it's in the East region, it's around 16 hours on average. So if you have plans to run just like 1 week a month, or maybe just during business hours, you can definitely save money by using the on-demand billing and pausing and resuming your resources when needed. So what we've done is actually implemented a solution, command line utility, to make it easy for you. So you can easily pause and resume your cluster in the public clouds with just right out of the box when you deploy Greenplum in the cloud with an easy to use command line utility. You can save money by suspending your processes when you don't need it and resume when you do need it. So you can take advantage of the billing policies in the cloud and save money. So did you know that you can change the instance type of a virtual machine after it has been deployed? And so if you're not familiar with instance type is regularly used in the public clouds. It is simply a predefined configuration of a virtual machine in terms of number of virtual CPUs, memory, and network bandwidth, and also disk throughput limits. So a family of, or a series of instance types will map back to a physical host. So that's also where you get the actual CPU type for the entire series. So the family or series of instance types have usually a staircase of billing, or configuration. So as you go up each staircase, you double the amount of RAM, CPU, and also the cost. So for example, in Amazon, an R5 4X large has twice the compute of an R5 2X large, but it also has twice the cost. May have skipped us. Oh, I didn't. So why do I care, right? Why do I care about changing instance type? Well, you can leverage this to quickly scale up your compute capacity and scale back down when you don't need it. So it's a way to, because it's tied to cost, it's a great way to help save you money by dynamically changing the configuration of the virtual machines that you have running in your cluster. So what this really does is enable you to pay for only the compute resources you need when you need it. You don't have to over provision so that you can handle that 1 day a week and when there is more demand, right? So if Monday comes in and there's a lot of demand, you can scale up to get more compute resources and then scale back down to save on money. Or for instance, when you first deploy a cluster, you may not have very many users on the database, so you can start with a smaller instance type and then scale as you go forward. We may have a command line utility to make that easy for you to change. So did you know that in the cloud that you can modify the disk attributes of a cluster? And they can differ between clouds, but they all have the ability to change the disk size of your cluster. You can always increase the storage capacity. So this is a typical, I'm sorry, this is a representation of how you can grow your cluster from terabytes initially to petabytes when you actually need it. You can start off with petabytes of storage and you pay for all that storage, but if it's a brand new cluster, you're not gonna have any data there, so why pay for all that extra storage? So we make it real simple to start small and grow your capacity as needed. So you're not having to pay, again, for those petabytes worth of storage um, when you don't have that demand or that size of data quite yet. You don't have to migrate to a new cluster to grow the storage. And in most cases, you don't even have to stop the database. In Amazon and GCP, it's completely online activity where you grow the storage while the database is up and running, and you just get more storage. So quick question though. So did you know that infrastructure as a service will actually replace um, any node in the cluster that fails? It becomes unhealthy. So that we have actually leveraged this to make things more cost effective. So go forward, please. What we've done actually is taken advantage of this self-healing that infrastructure as a service provides. So if any node in the cluster fails, the IaaS will automatically replace the virtual machine. So what we've done is gone one step further and hooked into this to automatically uh, execute the commands necessary to uh, restore services 100% so that you're up and running completely normally again without any user intervention. So this is a typical infrastructure or deployment of what you see of Greenplum database, usually on-premise, right? Because you have a master node and you have, which the master node accepts client connections, it does query planning, it oversees query execution, dispatches the queries out. There's a standby master, and the standby master is sitting idle, and it's waiting for the master to fail. And in an on-premise situation, we recommend a dedicated host for this. So that way, if the master host were to fail, you can run for a significant amount of time on the standby master and have high availability and not have to put down, not have the database down. And the segment workers, the SDW1, SDW2, SDW3 there, has the actual sharding of data. So all the data is distributed across there. So what we've done in the cloud, because we have that self-healing technique, we have the ability to move that standby master process off of a dedicated virtual machine onto the first segment host. So if any host fails in the cluster, it automatically recovers. So we have put that standby master process on the first segment host. So what that does for you is it saves you money because you don't have an idle virtual machine sitting there waiting for a failure to happen. And you also don't have to pay for the storage of that on that second standby master. And you're not paying licenses to us for the Greenplum license on that standby master host. So did you know that the IaaS providers all have disk snapshots, and they're all incremental and actually relatively cheap? What we've done is we've had take the data volumes within the cluster and create snapshot backups, and then we can restore that later. We have a command line utility that makes it simple to execute to create a backup of the entire cluster in parallel. So and it runs in very, very quickly because it just takes a minute for the data volumes to get all started with the snapshots, and then you can start the database again. It is inexpensive, like at Amazon, they charge the S3 cost because that's where it's actually persisted. And they're incremental. So if you take a snapshot on Monday, the next subsequent snapshot on Tuesday will just have the difference stored, and that's what you're paying for in like Amazon. So you can also do on-demand disaster recovery. So what this means is like if I'm doing those snapshots and with our command line utility, I can also use that same command line utility to copy the snapshot from one region to another. So let's say in Amazon, you have a cluster in US East, and then you're copying that snapshot to the West region. there's suddenly now an issue in US East, and you're like, well, I got to restore my cluster. What do? With this scenario, you can create a new cluster on demand and then restore the snapshot in the US West. So this gives you an on-demand disaster recovery solution, and that helps you save money. One is because you're not paying for an idle cluster in the US West, waiting for the East cluster to die or the East region to go offline, and you're not paying for the storage of it or the licenses of Greenplum for that secondary cluster. You're just paying for the compute resources you need when you need it. So with Greenplum in the public cloud, you can save, can mean big savings because we have really worked hard to not only make it perform well, but also leverage the IaaS to provide features to give you cloud savings. And thank you very much. I really did appreciate giving me the time today to talk about how we can save money or help you save money when you run Greenplum in the cloud. Thanks.
Thanks, John. The ability to actually have this perfect merge between what some legacy customers are used to having with regards to their deployments of Greenplum, as well as that merge into what new folks are looking for in a cloud-native environment. Like this blend of Greenplum being able to do on-demand DR and scale independently compute and storage on t-shirt sizes is super exciting. So thanks for the talk.
Thank you.